Now let's see some definitions. If capital G has a UV path, right, so which means if U is a vertex and V is a vertex, and if there is a path between them, so there can be any number of paths. If there exists at least one path, then the distance from U to V is the least length of a UV path. So out of all the paths possible from U to V, you have to find out the least one, right? That is the distance from U to V. It is generally represented as du comma V, right? I'll take this example and I'll tell you what we mean by that. Now in this one, let us say I want to find out d of 1 comma 2. So what is the distance from 1 to 2, right? So how many paths are possible? One path is this one, which is containing direct edge. Other path is this one, and other path is like this, right? So there are three paths possible here. Out of all this, what is the shortest one? This one, right? Therefore d of 1 comma 2 equal to 1. Similarly, what is d of 1 comma 3? If you see d of 1 comma 3, from 1 to 3, how many paths are possible? See, one path is containing two edges, and other path is containing more edges, right? Therefore the least one is 2. Therefore d of 1 comma 3 is 2. What about d of 1 comma 4? d of 1 comma 4 is one path is containing 1 2 3, and other path is containing 1 2. See this, one edge, two edges, right? Therefore 1 comma 4 is 2. What is d of 2 comma 1 comma 5? So 1 comma 5 is, it is saying only 2, and from this side it is 3, and from this side it is 4, right? Therefore 2 is the answer. What is d of 1 comma 6? So d of 1 comma 6 is directly 1. So no path can be less than 1 length, isn't it? Unless you are talking about the same vertex. Now what about d of 2 comma, see 1 comma 2 is over, therefore 2 comma 1 is also over, so 2 comma 2 is not required. Therefore let's go to 2 comma 3. What is d of 2 comma 3? They directly connected, therefore 1. So what is d of 2 comma 4? Directly connected, therefore it is 1. What is d of 2 comma 5? So you have to reach 5. Here there is 2, here there is 3, here there is 3. So 2 is the answer. What is d of 2 comma 6? d of 2 comma 6 is 2 here, 3 here, right? Therefore 2. Now what about d of 3 comma 1? 3 comma 1 is over, 1 comma 3, and 3 comma 2 is over because 2 comma 3 and 3 comma 2 both are same in undirected graphs, right? Now 3 comma 3 is not required. What about 3 comma 4? So 3 comma 4 is, see this, these two, there is a direct link, directed, therefore it is 1. What is 3 comma 5? d of 3 comma 5 is equal to, right? So from 3 to 5 the distance is 2. This is the least distance. If you go through the other way, it is going to be more. If you come to the other way, it is going to be more, right? Therefore the distance, the least path is 2. What about 3 to 6? 3 to 6 it is 1 2 3 or 1 2 3, right? Only 3. So 3 to 6 it is 3. What is d of, okay, 3 is over. We have dealt with all the cases starting with 3. Now let's see 4. What about 4 comma 1? 4 comma 1 is over, 1 comma 4, and 2 comma 4 is also over, therefore 4 comma 2 we need not do it, and 4 comma 3, since 3 comma 4 is over, we need not do it. 4 comma 4 is anyway not required, and 4 comma 5. What is 4 comma 5? Directly connected, therefore only 1. Now what about 4 comma 6? 4 comma 6 is connected this way, right? Therefore 2. Now what about 5 comma 1? So 1 comma 5 is over, and 5 comma 2 is also not required, and 5 comma 3 is also not required, 5 comma 4 is not required, 5 comma 5 is not required, so only thing remaining is 5 comma 6, right? So what is 5 comma 6? Now 5 and 6 they are directly connected, therefore it is 1. And anyway 6 comma 1, 1 comma 6 is already done, 2 comma 6 is already done, 3 comma 6 is done, 4 comma 6 is done, 5 comma 6 is done, therefore no need to do anything with 6. So these are all the distances. Okay, this is how you find out the distance. So what did we do here? Between any pair of vertices, we have found out all possible paths, and among all these paths, the shortest one is going to give us the distance. Okay. And now look at the next one. See, the reason why I found out all the distances is it is useful for the next definition. Now the diameter. So the diameter is generally, okay, see, one more point is there. If G has no path between U and V, then D of U comma V is infinite. So when will there be no path? In case if it is an undirected graph, only when they are disjoint, right? I mean disconnected, you can say disconnected. So what I mean by this is, let us say you have a graph like this and you have a vertex here. Now this vertex is not connected to any of the vertices here, right? In this case, what we can say is distance from this node to any of these nodes is infinity, because there is no path at all. Okay, coming to the next one, the diameter. So diameter is a property of a graph. So the diameter of a graph is maximum of U comma V such that U comma V belongs to the vertex set of G, maximum of all distances. So what does it mean is, it is not that you have to find out the maximum distance between two vertices. You have to find out the minimum distance between all pairs of vertices, and out of this value you have to find out the maximum one. Try to understand this. Generally you might get it wrong. The diameter is maximum of, you have to find out for every pair what the distance is, and then out of all these distances you should find out the maximum value. It does not mean that it is the maximum distance between two vertices. Got it? So what is that? You have to find out the shortest distance between two vertices for every pair, and out of all those values you are supposed to take the maximum value. Got it? So what is the diameter? So diameter in this one is 3. Why? Because the maximum value is 3 here. Got it? Now by knowing about the diameter of a graph, what you can understand is, from any vertex you can reach to any other vertex in a distance less than the diameter, less than or equal to diameter, right? If the diameter is equal to 3 for this graph, what does it mean? From any vertex you can reach any other vertex in a distance less than or equal to 3, which means there will be a path whose length is less than or equal to 3 to reach from a vertex to any other vertex. In case if the graph is disconnected, then what happens? So you will clearly see that the distance for this one is infinity for many cases. Therefore you will get the maximum distance as infinity, which means you cannot reach every vertex. That is the meaning of it, right? So diameter is going to give us the upper bound of the number of edges required to reach a node from other node. Got it? Okay, next one is the eccentricity of a vertex. So when we talk about eccentricity, we are talking about a vertex. When we talk about the diameter, we talk about the graph. Therefore diameter is a property of the graph. Coming to eccentricity is the property of a vertex. Now what is it? The eccentricity of a vertex U is, now see this, maximum of V such that V belongs to V of G and D of U comma V. So what I mean to say is, if you want to find out the eccentricity of 1, right, find out from 1 all the distances to all other vertices. Once you find out the distances, you find out the maximum value. That will give us the eccentricity. For example, if you want to find out the eccentricity of 1, vertex 1, from 1 try to find out the distance to all other vertices, and among all these values you try to find the maximum one. So what is the maximum value? 2. Now what does this eccentricity of a vertex gives us is, from a given vertex, what is the worst case, or what is the how can I say it? So what is the longest number of or what is the highest number of edges required in order to reach any other vertex? We can think of it that way, right? So which means, for example, in this case, if you want to reach any vertex from vertex 1, it will not take us more than 2 edges. That is the meaning of it, right? So what is the vertex eccentricity gives us? It is the maximum number of edges required from a vertex to reach any other vertex. Got it? So in this one, if you try to find out, the eccentricity of 1 is 2, the eccentricity of 3 is 3. So why is the eccentricity of 3 is 3 is, if you observe it, from 3 to 6 you cannot reach in a path less than 3, that is why it is 3. right? And also eccentricity of 6 is also 3. Why? Because from 3 to 6 you cannot reach in a path less than 3. That is why it is 3. Got it? Okay. And next one is radius of a graph. So the radius of graph is minimum of eccentricities. Now once you find out all the eccentricities, right, then you find out the minimum one. So what is the least one? The least one is 2, right? So minimum of all eccentricities is going to give us the radius of the graph. Got it? Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%. But all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.